Oh, hey, I'm Staff Sergeant Mendiola, and I'm going to teach you the importance of friction loss, how to calculate friction, and also how to apply it on the fire grounds. First of all, I want to start off by saying congratulations to everybody that completed the course. This will be my final speech, which will be an informative speech on friction loss. Okay, so what is friction loss? As on scene, as a fire pumper, driver, operator, it's important to know the amount of friction that's going to be lost at the end of the nozzle. When we get on scene to a fire, the most important job for a driver is to apply enough pressure to put out the fire. Okay? So this is a basic math course that I teach to a lot of our guys, and it's important, again, for the driver to understand how to do this. The last thing we want, me as a crew chief bringing in our firefighters in to go and fight a fire, is to not have enough water pressure to knock down the fire. So again, it's key for a driver to know it. Now I'm going to teach a couple examples, and hopefully this will be basic math for everyone to understand. Causes friction loss. Well, friction loss is caused by the length of the hose, the amount of water that is being applied through the hose, hose diameter, hose condition, cupping condition. Also, there are other determinant factors like elevation gain. When we're working against gravity, you're going to have water water loss or pressure loss. Okay. So let's think of it as basic. Okay. Let's think about a garden hose. Okay. You turn on your spigot. You apply water through it. You have connected 800 feet of hose. By the time that water gets to the end of that nozzle, or the tip of the nozzle for your garden hose, you're going to have a lot less pressure than you would have if you only had 100 feet of hose. Okay, same thing if you had that 100 feet of hose and you brought it up 100 stories. You probably aren't going to have that much water pressure. So it applies the same thing for a fire hose. Okay, so I'm going to go ahead and demonstrate the formula and also do a basic example.
Okay, so let me demonstrate friction loss. So the equation for friction loss is friction loss equals the coefficient, which is always a constant, times the quantity squared times the length. Now friction loss, FL, stands for friction loss, the amount of friction that's being applied on the fire hose. The coefficient, which is a constant, never changes but an approximation of a number, is on a table which I'll demonstrate. Next will be quantity, which is represented in gallons per minute, divided by 100. Next will be length. L stands for the length of hose, which gallons per minute will be applied through, divided by 100. Okay, so let's write the friction loss equation and do an example. So friction loss again equals the coefficient times quantity squared times length. Okay, for this example we're going to use an 1 3/4 line, and the coefficient for 1 3/4 is 15.5. 100 gallons per minute will be the quantity for this example, squared, times 100 feet of 1 3/4. We'll divide quantity by 100 and also the length of hose by 100. Okay, now doing basic algebra, we'll bring down 15.5 times 1 squared times 1. Next, we'll multiply 15.5 times 1 times 1, which will bring us to 15.5 pounds per square inch, or PSI.
It gives everybody a better understanding of friction loss. Now there are a lot of other equations and formulas in the fire department and that driver operators will have to know and that we have to learn. That is just a basic friction loss equation that we may know. So hopefully that gives you a better understanding of why friction loss, what causes friction loss, and how to calculate for it. So I hope everyone has a good summer and hope everyone takes it easy.